Hello friends, good afternoon and welcome to Recite Live Lectures. Dear friends, today in Network and Graphs we will be talking about data link layer, its functions and protocols. To discuss this topic we have with us our subject expert Professor D.K. Lobial. Professor Lobial is professor in School of Computers and System Sciences, JNU. Without further ado, I would like to welcome Sir to our studios and request him to start the lecture. Welcome, Sir.
Thank you very much. We have been talking about the various layers in computer network, and one of the layer is data link layer, and in this lecture we are going to cover what are the various functions and the protocols used at data link layer and what is the relevance of data link layer. So, the topics which I will cover is why framing is required for transmitting of bits rather than sending all bits as one stream. We divide bits into frames and then transmit them. So, why do we need framing? Second is the error control. During the transmission through the physical layer, the errors is introduced in the bits or in the signals, that the signals get error because of noise, and therefore, this error is reflected in bits. So, the 1 becomes 0, 0 becomes 1. So, how do we control, or how does the network controls the error in the frame? And then we will talk about flow control, where while the frames are flowing on the network from a sender to a receiver, if there is a mismatch of speed, that the sender sends fast or receiver is not able to receive them that fast, or it is a slower receiver, then the problem is that a lot of data may get dropped. Reason is one, there is the buffer space of the receiver may not be sufficient enough to receive and collect one, and the device itself may be slower, receiving device may be slower in receiving than the sending device at its speed. So, that means what we need is we need to regulate the flow of the data, so that we will send as much data as a receiver can accept, right. And then we probably talk about one protocol as DLC, which has been used. Now, what are the functions of data link layer? So, one of the primary function of data link layer is to provide service interface to the network layer. That means, if you those who are doing some programming, that means this layer must provide a set of functions or some mechanism or interface, so that if anybody is writing or developing a protocol at the network layer, how does he uses the services of data link layer? That means, data link layer must provide some interface or a set of functions which can be called by network layer, so that it can transmit data there and receive the data coming at the data link layer. So, that is called a service interface. Service interface can be one way seen as a set of functions or APIs, right, application programming interface. Now, other service it has to provide, or the function it has to do, is dealing with the transmission errors. If there are error in the transmission, they must be taken care of. That is another function which data link layer should perform. Then, as I said, the regulation of the data flow, because slow receivers should not be overflowed by the fast sender, or the receiver should not be underutilized, and so on and so forth. Then, to provide these functions, data link layer should provide certain services to fulfill these functionalities. One of the service is that it must provide services to network layer. So, in the hierarchy when we discussed, we said that a lower layer in the network hierarchy provides services to the higher layer just above it. So, data link layer falls below the network layer. So, therefore, data link layer with the same logic provides services to network layer. So, one of that is what the services must provide. It must do framing, error control, flow control, which I said these are the topics which we are going to cover in this network. Now, while providing services for the network layer, and if you remember in OSI protocol model, what we said is that the network layer or internet layer in TCP/IP is a connectionless layer. That means before transmitting of data from network layer to another network layer to another system, there is no connection established. So, it is a connectionless. As when a network layer ready, it simply transmits data to the next system. That is where we say it is a connectionless service. So, when the network layer is providing a connectionless service, how this connectionless service to the network layer is provided by data link layer. So, one, that it may be acknowledged connectionless service, that means data link layer is transmitting data without receiving any acknowledgement. It may receive acknowledgement, but it may be connectionless, which is called acknowledged connectionless service. That means no connection is established, sender straightway sends data to the receiver and receiver sends acknowledgement. In the first case, when I say unacknowledged connectionless, there is no connection established. That is, as when the data link layer is ready to transmit the frame, it will straightway transmit a frame to the receiving end, and the data link layer on the receiving end will receive it, but it will not acknowledge that whether data has received or not. That means the sender do not have knowledge whether the data which the sender transmitted has been received by receiver properly or not. Like in a postal system, when you deliver a postcard or an envelope on the letter box, it goes and you never know whether it has arrived or reached at the destination or not. That is what simply a datagram service, or you call a connectionless service. And then if you put an acknowledgement card with your envelope, it goes and the acknowledgement card is supposed to come back to you to give you an information that it has been received by the recipient of the letter. Then we can have acknowledged connection oriented service. That means before transmission of data, a connection is established between the sender and the receiver. We are talking of logical connection in all. So, a logical connection is established between the sender and the receiver. After that, the sender will send frame, and these frames, after receiving successfully, will be acknowledged by the receiver. That means receiver will send a frame which is acknowledgement frame to the sender, right. So, this is called acknowledged connection oriented service. Same like telephone connection, you make a call, you connect by dialing a number. Once a connection is established, you hear an hello from the receiving side, that means they are acknowledging or dialing, then you start talking and they will show. That is what is called acknowledged connection oriented service. Now, that means what we are saying is in an acknowledged connectionless service, frames are sent independently between source and destination. That means each frame is independent of others, and no recovery for lost or erroneous frames. If there is error in the frame, it is not taken care of, there is no recovery. If the frame is lost, there is no mechanism, it is lost. Then appropriate for low error rate. These kind of services are useful when the error rate in the channel is low. That means channel are more reliable and there is very little probability that the channel will have an error. Therefore, such kind of unacknowledged connectionless service may be useful, because the probability of error in the channel is low and you transmit data. So, you will not waste time in waiting for acknowledgement. So, keep on sending, and we are assuming that since the channel's error rate is very low, and we are assuming that all data will be received correctly by the receiver. That is what the assumption is. And this is also appropriate for real time traffic, where the late data is worse than bad data. In certain kind of situations, the late data may be worse than bad data. Data may be corrupted, but it must reach timely. That is what the situation is. So, where in that kind of situation, you would not prefer to wait for acknowledgement. So, there unacknowledged connectionless service, and you will also not wait for establishment of a connection. So, the time spent in connection establishment and acknowledgement will be saved, and data will be delivered faster. So, the situation where real time traffic, where you say late data is worse than bad data. So, that kind of situation, this unacknowledged connectionless service is useful, and this is used mostly in all local area network. Then we have acknowledged connectionless service, that each frame is sent individually and is acknowledged by the receiver, and that means the sender sends frame and then waits for the acknowledgement, and acknowledgement is sent by the receiver. So, therefore, the lost or erroneous frames are recovered by transmitting. That means, if the sender knows that the frame which it sent has lost or has occurred an error in the frame, therefore, it can retransmit the same frame. So, next time the frame may reach correctly without any error. So, this retransmission, if the frame is lost or it has error, the retransmission is done after a certain time interval. It is not that you transmit and then again transmit, and that is or by receiving a negative acknowledgement. That means, if the frame is lost or error has occurred in the frame, so after receiving the erroneous frame, the sender will send an acknowledgement, negative acknowledgement, saying that the frame which I received has an error, and based on that acknowledgement, the sender may retransmit the frame after waiting for a certain time interval. And these kind of situation is used in wireless systems where the links are unreliable. So, therefore, we transmit data frames and wait for acknowledgement. Now, then we have acknowledged connection oriented services, where connection is established before data transmission. This is important, and the connection will be released at the end of the data transmission. When the transmission of data is over, the connection is released. So, that means a connection is established for a session of dialogues between a sender and a receiver. That dialogue will involve transmission of frames. So, frames are sent over this connection, whatever connection, logical connection you have established or virtual connection, and the frames are sent over that connection, and each frame will be given a sequence number. If in a message which we are willing to transmit, if it has n number of frames, then each frame is given a unique sequence number. And then why we give a sequence number? So that even if the frames are not received in the order in which they are transmitted, that means they are not received in the correct order, and then looking at the sequence number, they can be arranged in the right order, because we know the sequence number 2 will follow 1 and 3 will follow 2, and therefore, they can be combined or again reassembled in the right order. And if you look at this, the packet, the sending machine will send a packet. If it is coming from the network layer, what does data link layer will do? It will make a payload. Payload means the data which is in the packet, and then this will add its own header, it will add its own trailer, and then this is called a frame, and this frame is transmitted to the receiving machine through a physical connection, or that is through a physical layer, and the receiving machine will remove this header and trailer, and the payload load field is giving as a packet to the network layer of the receiving machine. That is what the relationship between a packet and a frame. That means the frame comes from the network layer, and this is made as a payload in the frame by adding header and trailer. Now, it should not give an impression that the entire packet which is coming from the sending machine becomes a payload in a frame. That is not true. Reason? Because the packet size may be larger than the frame size. Then what do we do? That means a single packet coming from the sending machine, if you look at the left side of the diagram, the packet coming from the network layer of a sending machine may be divided into multiple pieces, and each piece may be called a payload field. If say a packet is divided into k pieces, So, that means we will make k frames. Each piece will be put as a payload and then it will have a header and trailer, and this becomes a frame, and then we will transmit that frame and then next piece. So, that way if a packet coming from the network layer is divided into k number of pieces, then we will make k frames, and by adding the header and trailer, and this k pieces will become payload, and so on and so forth. Now, if you look at why do you go for framing, bit streams sent by physical layer are not guaranteed to be error free. That means, what we have been saying, that the bits which are transmitted actually by the physical layer, they receive error because of the noise or because of interference in the channel. And then these bit streams by the data link layer is divided into frames to validate the errors. Now, why it is important that we must divide these frames into these bit streams into frames to validate errors. Now, as we said that if there is an error in the frame has to be retransmitted. If that is the case, if you send an entire bit stream as one frame, then what will happen? Even if there is an error in one bit, then the entire frame has to be retransmitted. That means, if I say, if you have assume, this is a very hypothetical condition, if you have a bit stream of 1 megabyte or 100 kilobytes, even I take that, or 100 or 1 megabyte, if I make a frame of 1 megabyte as a payload and then put header and trailer, if I transmit this 1 megabyte frame, if there is error even in a single bit, that means rest of the bits of 1 megabyte are error free, only one bit has an error, that means the frame has an error. Now, the entire frame of 1 megabit has to be retransmitted again. So, therefore, what do you do? Rather than making this entire bit stream of 1 megabits as one frame, divide into say 100 frames. If I do that, now if I assume that 1 megabyte is divided into 100, then probably 10 kilobyte, 1000 kilobyte is 1 megabyte. So, therefore, if I divide it by 100, then 10 kilobyte is a frame. Then each frame is 10 kilobyte. If I transmit a 10 kilobyte frame, that means I will make it 100 frames. So, 1 megabit stream is being transmitted in 100 frames. Now, out of this 100 frame, I said 1 bit error may be in any one of the frames out of these 100 frames. Only that frame has to be retransmitted. That means, if only a frame which has an error has to be transmitted, then I am saving time. So, to have error control validation and to save time, I will divide into small pieces rather than a big large stream of data. Then these frames can be separated by time gap. That means, when the frames are transmitted, one frame transmitted, after a certain time gap the next frame, and then time gap next frame. Otherwise, it may be difficult to differentiate between the boundaries of the frames for the receiver. So, difficult to maintain that gap. Now, in addition to this framing, there may be other methods that may be used for timing. Now, one is that we can have a character count. If I am sending characters, how many characters you are sending, A, B, C, D, like this. If one frame sends 10 characters, then other frame transmit 10 characters. How do I differentiate between two frames? That means, each frame may have a separate starting pattern of characters and separate ending pattern of characters. That is what is called character stuffing. So, at the starting as well as ending character, I am stuffing some special characters, and the starting and ending flags with the bit. Or if I am sending bits, then instead of adding characters at the starting characters and ending characters, I will have certain bits, special bits, which I said starting bits and ending bits, that we call flags, and that is what is called bit stuffing. And the next is the physical layer has its own coding. If you can violate that coding, that may be starting, one violation may be starting of a frame, other violation may be ending of a frame. These are certain markers which can be used to differentiate between consecutive frames. Otherwise, while consecutive frames goes, ultimately a frame is a sequence of bits, and next frame is also a sequence of bits. So, you are transmitting a sequence of bits one after another one, and if the gap is not maintained properly, then on the receiving side it will be treated as if it is one frame. Now, otherwise the header of the frame specifies the number of characters in a frame, that is what is said, and that means when you begin with, and if you count those many number of characters, that you assume that is end and the next frame begins, and therefore, the receiver can easily detect looking at the number of characters in a frame as well as what you call the special characters, and these counts at times may garble, may mix up, and therefore, there is again a problem, and this is why this character count is not a useful method. Thank you. Now, what is said is this character count method may have a problem because the character counts may garble during the transmission. So, therefore, it leads to a desynchronization. The synchronization method, this is used as a synchronization method. If these characters themselves mix up, then it may not be useful. So, therefore, if you look at this, if you are transmitting these characters and there is a count, the frame 1 consists of 5 characters, frame 2 consists of another 5 characters, and so on and so forth, and then frame 3 then 8 characters, and so on and so forth. So, if you look at the frame 1, and then the first one, the A is without error and the B is with error, one error. If the bit or the character 7 has an error, then counting the boundaries is a difficulty. Now, to solve this synchronization problem, what is said, you add a special character. One is like say DLE STX can be a starting and DLE ETX can be the ending characters. You add in the header DLE STX and in the trailer you add DLE ETX. That will show if ETX DLE ETX character comes, DLE stands for delimiter, ETX end of the text or STX start of the text. Then a frame boundary is fixed, that this is the starting of a frame and this is ending of a frame. Even the problems occur here if the DLE STX are also part of the message. The message in terms of characters which we are sending, these special characters which we are using can also be part of the message. If they are part of the message, then the system will misunderstood whether it is a start or end of the frame, or how does it know that it is part of a message. So, this is solved by adding extra, instead of one DLE you will have another DLE. So, if two DLE comes together, it says that is part of a message, but this cannot work much. And if you look at here, we have a flag sending A, there is a flag, then B, frame A goes, there is a flag, then frame B goes after stubbing, and so on and so forth. And then we have frame delimiter, right, escape flag, escape, escape, DLE what you call, it can be called escape here now. And we keep on, if escape character itself is coming, then we have a one escape in the beginning, it said that is part of the message, and so on and so forth. Now, another is rather than character stuffing, we may have a bit stuffing if you are transmitting ASCII, if you are not transmitting the characters. If you are transmitting message as a ASCII, then character stuffing may be useful, but sometimes we transmit bits rather than characters, even the characters are ultimately converted into bits. So, if you assume that a frame rather than is a sequence of characters, we assume that is the stream of bits, and characters, these bits can be converted into characters at a higher level. When the message is interpreted, the bits are converted into characters, and then the message, the meaning of the message is interpreted. But as far as transmission in the network is concerned, we assume that it is a transmission of bits. If that is the case, then how do you differentiate between two frames? Because one frame is a sequence of bits, the next frame follows with a sequence of bits. Then it may be a long sequence of bits. How do you differentiate? So, the spatial bit pattern may be used as a flag in the beginning and end of the data. The flag pattern may also, but the problem is if you use 0, 1, 1, 1, 1 6 times followed by 0 as a flag, that means if you get a bit pattern of 0 and followed by 6 ones followed by 0, we call it a starting of a frame. Then we send bits, then while we are sending next frame, then we again first send this pattern 0 followed by 6 ones followed by 0. So, anytime when the receiver comes across a 0 followed by 6 ones followed by 0, say, we said that means up to this point all bits received are part of one frame. Now, the bits which are being received after this pattern will be a new frame. If you look at this, fine, but if this bit pattern of 0 followed by 6 ones and 0 also occurs as a part of the bit pattern I am sending, then there will be a confusion again, right. So, look at this, I am sending I am sending original data, while I am sending this, then I have 0 1, this is 0 1 1 0 for 6 times 1 and so on and so forth. And if you look at this bit pattern, what I do is I stuff a 0 here to so that there is a flag in between. So, if the data as they appear on the line, if you look at B, then we stuff some bits. Now, let me go back. Now, if the same pattern occurs, how do you do? This is solved by stuffing 0 bit after 5 consecutive ones, and that means instead of 6 ones there could be 7 ones. So, you are adding one more, right. So, this is what we are doing here, we are adding a 0 after every 5 ones. So, that means this is called a bit stuffing, and anywhere the same pattern comes after 5 ones, because there is 0 followed by 6 ones, if that pattern comes after 5 ones, I will add a 0 and I am adding in this figure. So, therefore, it will not be treated as a flag. So, this is what called bit stuffing. Now, this is where we identify the boundaries, but other function of data link layer was error detection and correction. Now, the first question comes, how do we detect errors? Now, assume that a frame of 1 1 0 1 0 1 0 is transmitted, and then if there is an error, how do you identify that? One of the method is that simply what you said, this bit pattern of 1 0 can be represented as a polynomial. I am not going in the mathematical details, this is simple, but even if assume that I will fix a small bit pattern which is smaller than this frame size, and if I divide the message, the frame which I am sending by some smaller bit pattern, and it may not be exactly divisible. So, at the end I may get some remainder. So, if I add this remainder to the bit pattern, that is a frame pattern, then what I will get is it will become an exactly divisible by the divisor. Say for example, if you are sending 50, let me put it this way, and if you are dividing it by sending 49, if you are dividing it by 5, then 49 is not an exact multiple of 5. So, 1 and the remainder is 4, right, it 9 times, the remainder is 4. Now, right, if I subtract this 4 from 49, what happens is 45 is the exactly divisible by 5. But in binary system, what happens is, rather than subtract, I will add. The subtraction is also seen as addition. So, rather than in binary, rather than subtracting, I am adding. By adding, I will make it exact multiple of the divisor. And if I, after adding this, if I transmit it on the other side, if I divide it by the same pattern, I must get a remainder 0. If I get a remainder 0, that I assume that there is no error. On the receiving side, if I again get a remainder, that means there is an error. That is what is the logic of division or checksum error or error detection mechanism is used. Now, since error correction, that means we need extra bits to be put in the frame so that the error detection takes place. So, we need additional bits. Now, if you go for error correction, more additional bits are required. So, therefore, in a smaller simple network which you use in our organization, it does not go for error correction, and it only goes for error detection. If there is error detected in the frame, it should send an acknowledgement to the sender that there is an error, and then the sender must retransmit it. The small local area network, we follow error recovery by the mechanism of retransmission. We do not have a mechanism of error correction. But if the transmission is to a longer distance, where the delay is more, probably the error detection then retransmission may be a costly mechanism. Say for example, you are transmitting a frame to a satellite far away at the geosynchronous, assume that, then it will take longer time to reach, the frame will reach there, and then there is an error, then acknowledgement will come, it will take more time, then you retransmit the same frame. The time delay occurred is too long. In that situation, rather than retransmitting mechanism, add some additional bits in the frame itself and correct it there. So, it is the time versus the time taken to transmission versus that, rather than retransmission it takes more time. To save that, you add few more bits. So, adding few more bits may not take as much time as it may be taking in retransmission. So, the question is whether retransmission takes more time or adding certain extra bits in the frame takes more time. So, based on that you decide whether correction is a better mechanism or retransmission is a better mechanism. Now, let us come to flow control. Now, when a sender transmits faster than the receiver can accept, then in that case the receiver gets swarmed and data gets lost. So, it has no space to accommodate, the data will be lost. And the solution to this is a flow control mechanism that will regulate the transmission of data. So, the sender must transmit as much data as the receiver can accommodate. So, there will not be an overflow and data will not get lost. So, the regulated sender and needs feedback from the receiver. That means, how does the sender knows that it cannot accommodate more data? So, that means you need a feedback kind of a system. That means the receiver must be sending some kind of feedback about how much buffer space it has got. So, if the receiver can only accommodate 20 bytes, it must send with the acknowledgement, please send me only 20 bytes, not more than 20 bytes. So, next frame which the sender is transmitting, it will send a frame consisting of only 20 bytes, so that it can be accommodated on the receiver. So, that is a kind of a feedback system. Now, there are two kind of protocols for flow control at the data link layer. One is a stop and wait, and this stop and wait can be for a noiseless channel, it can be for a noisy channel protocol. So, let us take simple stop and wait. What happens in the stop and wait? Right, the data link layer at both the sender and receiver are ready for receiving and sending the data. And and what we want to ensure is the frames are not damaged and lost during transmission. If that happens, then we have to retransmit. And further is no infinite buffer is available. So, the buffer space at the transmitter and sender both is finite. So, and further is an acknowledgement is sent after each frame. So, what is happening ultimately is, if you look at this, that a sender will send a frame, then stop. Now, wait for the acknowledgement from the receiver. That is what the stop and wait means. So, it sends a frame, then stops sending, then waits for the acknowledgement. The moment acknowledgement is received, then it will transmit the next frame. That is what stop and wait mean. So, that means if the frames are damaged during and lost, if damaged or lost, if the damage, the negative acknowledgement will come, it will retransmit the same frame. If frame is lost, the sender is not going to get any acknowledgement, then it has to retransmit after a certain period of time. Now, look at this. What you assume, if you assume that transmission time is 1 unit and propagation delay is alpha. Now, you have to differentiate between both times. Propagation time is how much time a bit takes to travel from a sender to the receiver. That is time taken by a signal or a bit to travel from a sender to the receiver. That means it is a speed of signal, it depends on the speed of signal and the distance between the sender and the receiver. Whereas the transmission time of a frame is how much time a receiver or a transmitter takes to put an entire frame on the transmission medium. If it is medium is a wire, say for example, a bit is put on the wire, the next bit, and it keeps on traveling. So, if you have a frame consists of 100 bits, how much time it takes to put all 100 bits on the transmission medium? That is my transmission time. So, transmission time of a frame is considered to be 1 and alpha is a propagation delay. There are two situations. One, the transmission time is larger than the delay, propagation delay, situation A, and situation B is the propagation delay is larger than the transmission time. So, what will happen in the first case A, where the delay, propagation delay is larger than transmission time. That is, if you assume one frame takes 1 unit time, that is time taken by a frame we are considering that is 1 unit, and with respect to that the alpha is greater than that 1 unit. Now, if the transmitter at time t0 it starts sending a frame on the left hand side figure A. Now, it starts sending at t0, then what happens is it puts one bit on this wire and the next bit and next bit. Since alpha is smaller than that, what will happen is that the bit propagation delay is smaller, that means the bit will quickly reach the other end, and still the entire frame has not been transmitted. That means first bit is put on the wire, the next bit is put on the wire, next bit is put on the wire. By the time the first bit might have reached to the other end. That means the frames are quickly transmitted and then quickly reached other end, and even if the transmission is not over, the bits are reached to the other end. what will happen is you keep on transmitting, and the first bit you send has already reached there, and before you complete transmission of what frame. So, in that situation what will happen is the entire channel is underutilized, and then you have to wait for the acknowledgement as well. So, in this situation the channel will be underutilized. And in second case, when alpha is even this is not reached there, that one bit your transmission time is, first situation the transmission time is smaller than the propagation delay. That means you have finished transmission of a bit, and even or a frame, even the frame has not reached at the receiver, because it will take more time to reach, because alpha is greater than 1, and you have completed transmission, but the frame has not reached at the R. That is what the situation is. That is what you see at t0 plus 1 you have finished transmission and the frame has travelled only some distance. At t0 plus alpha, when the frame has reached almost closer to R, and the figure A and third row, and then what happens is t0 plus alpha plus 1, that means the acknowledgement has also come, the acknowledgement is coming and it is reached there, and so forth, that at t0 plus 1 plus 2 alpha it has gone there and the acknowledgement has come. On the right hand side it is opposite, alpha is less than 1, that means transmission time is larger than the propagation time. What is happening is, if you look at the figure B and row 2 at t0 plus alpha, even if the first bit has travelled closer to R, even the last bit is now transmitted by the transmitter. So, the entire channel is occupied, it is also inefficiency of a protocol. Now, if you have noisy channel where the frames can be lost and acknowledgement can be lost, then what will happen is, and acknowledgement can also be lost in the noisy channel, thus frames may be duplicated. You send one frame, acknowledgement is lost, you again retransmit, so the same frame has reached at the receiver twice, so it is a duplication. And then therefore, it is important to number these frames to avoid duplication, and sender must wait for positive acknowledgement with a retransmission, so that it again will not retransmit the same frame, and then only after that the next frame is transmitted, and after a positive acknowledgement is received, only then next frame is transmitted. But in some cases, if the acknowledgement PAR, positive acknowledgement, is not received, the sender waits for a fixed interval of time, then retransmits, and this is what is called automatic repeat request or retransmit, because it is automatically retransmitting after certain time interval if it does not receive acknowledgement. Now, the other protocol is a sliding window protocol. Now, the stop and wait has a problem that you send one frame, then wait for stop, then wait for acknowledgement, and then send next frame. That is, during the period, if you have a full duplex channel, while waiting for an acknowledgement, I am underutilizing my channel capacity. So, during that period probably I could have sent more frames, assuming that the reliability of channel is all right. So, therefore, the sliding window says transmit a fixed number of frames continuously without receiving an acknowledgement. It is not like send one then wait for acknowledgement. Keep on sending 1, 2, 3, 4, right, even if you are not receiving acknowledgement. Now, how many frames you will send in a sequence without receiving acknowledgement? Therefore, there is a window size. That means fix a window size. That means if you say that I will send k frames without, or w frames without receiving acknowledgement, if after transmitting continuously w frames, if I do not receive acknowledgement, I will stop. That is what it is. So, that is called a window size. That means number of frames one can transmit without receiving acknowledgement is called a window size. And then say for example, and then there are two issues. If you are sending n frames, consecutive k frames, it may happen that one of the frame is lost in the middle. 1 is reached correctly, 2 reached correctly, 3 is lost, 4th is reached, 5 is reached correctly. So, in between some frames are lost. Now, so 1 received, 2 received, 3 lost, 4 received, 5 received. What about 3? Now, retransmission has to be done 3, 4, 5 or only for 3. That is what the question. Based on that, we have two kind of protocols in sliding window. One is called go back n, other is called selective repeat. Now, in go back n, what it does, if I said if you have lost frame number 3 and frame 4 and 5 has reached correctly, then in go back n it will send 3, 4, 5. That means going back up to 3, the frame which has been lost, even if the frames after 3 are received, you are retransmitting 3, 4, 5. That is called go back n. And if you are transmitting only frame number 3, because 4 and 5 has been already received, that is called a selective repeat. Only you are selectively repeating or retransmitting that frame which is lost. Now, so therefore, if you look at this diagram, see if a sender sends frame 0, that is received, and frame 1 received with error, then frames 3 received, 4, 5, 6, 7, because the window size is 7. You can send 7 frames without receiving acknowledgement, but the frame 1 is lost. Then what to do? Only then it will send from 1 to 7 all frames. That is what the diagram shows. If the window size is 1. Now, with the selective repeat, you will send only frame number this. Now, that means what we are saying is, while you are transmitting, then in go back n, the point is, if I say 1 is sent, 2 is sent, 3 is sent, 4 is sent, 5 is sent, and 3 is lost. That means the receiver must store frame number 4 and frame number 5. If it stores them in a selective repeat, when only 3 is being transmitted and 4 and 5 are already stored there, then after receiving 3, it will send an acknowledgement for 3, 4, 5 together. That is called cumulative acknowledgement. So, there is a notion of cumulative acknowledgement in the selective repeat as well. In go back n, when 3 is lost, even 4, 5 is received at the receiver does not need to store 4 and 5 in its buffer, because it is no more required, because they are being transmitted again. If it stores, there will be duplication. So, when you have a limitation of buffer, in that situation the go back n may be better, and if you have the sufficient buffer, then selective repeat is a better choice. And the utilization of the channel in go back in sliding window is much better than the stop and wait, since stop and wait underutilize the channel. And with this we will complete this data link layer here. Thank you.
On that note, I would like to thank sir for this very enriching discussion, and thank you dear friends for watching our show. Stay tuned and keep watching. Thank you.